In previous lecture, discuss about the feature and advantages disadvantages of the PIC microcontroller. Today we are study to the architecture of the PIC microcontroller. The PIC microcontroller 16C6X and 16C7X is considered the starting point for the discussion. The architecture, pin diagram, memory organization and the instruction, etc. are specific to the PIC microcontroller parts 16C61 and 16C71 once the basic PIC philosophy is understood. The reader may to the for the PIC microcontroller. PIC microcontroller have hardwired architecture. The program memory and data memory are the separate buses. Instruction pipelining allows the instruction to the get executed a single clock. The execution cycle of the one instruction overlap with the phase program counter and the instruction register. On-chip memory, on-chip RAM, 8-level model PIC microcontroller rather than the drawing complete block diagram of the PIC devices. A simple block diagram of the 16C1 is shown the figure. For the block diagram of the PIC other devices, the PIC devices by the microchip. Then the first block diagram of the first block 16CXX ALU means arithmetic and logical unit. PIC microcontroller are the 8-bit microcontroller. The arithmetic and logic unit ALU, these devices are the 8-bit wide. It can perform operation on the temporary working register and the register file. One of the operands is normally in the W register and the other one is the either a file register immediate the constant depending upon the instruction executed. म्हणजे तुमचा ALU हा परफॉर्म करताना इन्स्ट्रक्शनच्या एक्झिक्युटिव्हवरती डिपेंड असतो. The ALU may affect the various flag namely as the carry flag, digit flag, zero flag in the status register. Then next one is the CPU register. The CPU register are include the working register, status register, FSR means file selection register, indirect file, PC latch, program counter. The first one is the status working register. In working register, the working register 8-bit wide. It contains one of the source operating during the execution of the instruction and may serve the destination for the result of the operation. This has the similar function as about the ALU of the microcontroller, means accumulator of the microcontroller. W register is only used the ALU operation and is not an the addressable register. Then next one is the status register. The figure shows about the status register. The status register contain flags and the register bank select a bit. The first one is the figure shows about the various bit of the status register. These are further register bank select means the RP0. Then second to reset status reset status bit means timeout bit, reset status bit power down bit, Z0 flag, digit carry flag and carry flag. The first one shows the carry bit. When the two 8-bit operands are added, the 9th bit result can be occur because the result of the addition may exceed 256 FFH. The 9th bit is the copied in the carry bit. During the subtraction, if the barrow occurs, the carry bit is cleared. Otherwise, it's set. ज्यावेळेस तुम्ही सबस्ट्रॅक्शन करता आणि त्याचा बॅरो ज्यावेळेस ऑकर होतं त्यावेळेस कॅरी बिट सेट होतं, त्यावेळेस कॅरी बिट क्लिअर होतं आणि दुसरे बीट आहेत ते सेट होतात. अ बॅरो विल नॉट ऑकर ऑफ द रिझल्ट. द सबस्ट्रॅक्शन इज ग्रेटर दॅन इक्वल टू द 0. Then next one is the digit carry bit. This bit indicates the carry from of the lower 4 bits during the 8-bit addition. If the set means there is the carry from the 3rd bit to the 4th bit position. This is useful binary coded decimal addition. If the subtraction of the BCD number, if there is the barrow from the 3rd bit to the 4th bit position, then digit carry blank is cleared, otherwise the digit carry is the set. The next one is the 0. Many arithmetic and logical instruction affect the 0 flag. For example, decimal flag म्हणजेच DECF instruction can be used to the decrement of the variable in the RAM. If the result is 0, then 0 Z bit is the set, otherwise Z bit is the clear. The next one is the T0 म्हणजेच timeout bit and PD means power down bit. These bits are used in the sleep mode of the microcontroller. During the sleep mode of the microcontroller can save the lot of power. After the coming out of this mode, the CPU can check these two status bits to determine which kind of the event responsible bring out of the sleep mode. Then next one is the RP0. RP0, this is the register bank select bit. RP0 is used to calculate the effective address in the direct addressing mode. To select the register bank 0, then the bit is cleared, and if the to select the bank 1, the bit is set. The next one is the FSR, file selection register. FSR is the pointer used to the indirect memory addressing in the whole register file. It must note that the PIC microcontroller, every instruction that can be used the direct addressing may also be used in the different ways of the for the indirect addressing mode. The only difference between indirect addressing mode is that the one has the write the address byte in FSR, then use the indirect म्हणजेच INDF in the instruction. Thus the FSR points to the desired memory location. Indirect through FSR. Indirect through FSR stands for the INDF. This is not a physical register. Addressing INDF register will causes the indirect addressing. Thus the meaning of the INDF can be through FSR, indirect through FSR, whereas the bracket indicate indirect addressing mode. Then next one is the PC latch, program counter latch. The figure shows about the content are the transferred PC to the PCL is written. PC latch can be independent, read or write like any other register. PC latch is the different from the program counter and the separate entity. Use of the PC latch as shown in figure. Any write to the PCL will be causes the content PC latch to transfer to the 13-bit program counter higher location. The next one, the PCL, program counter latch. PCL is the lower byte of the program counter. The PIC program counter is the 13-bit wide. It can be read like any other register. It can be like any other register. The PCL causes PC latch content to transfer to program counter higher bit content automatically. The program counter 16C6X associated with the 8-level stack. The operation of the stack is similar any other microcontroller. The program counter always point to the next instruction to be executed. In case of the subroutine, the return address is pushed on the stack and the after return from the called subroutine. This return address is the retrieved. Then next pin diagram of the PIC microcontroller. The figure shows about the pin diagram. First figure shows about the PIC of the 16C61 pin out, and second PIC microcontroller 16C71. Pin diagram of the PIC microcontroller 16C61 and the 16C71 in the DIP package as shown in figure. The PIC microcontroller 16C7X parts are the almost the same as about the 16C6X parts, except with and the additional feature of an analog to digital converter in the PIC 16C7X. Compare the pin diagram of the 16C61 and the 16C71 alternate function of the an AINO0 to AIN3, the analog inputs to the ADC in 16C71. Then Port A is the bidirectional input-output consisting the RA0, RA1, RA2 and the RA3. In case of the 16C71, pin number 3 RA4 is available and it is also the clock input to the timer 0 or counter 0. Output is open drain. In addition, 16C71 accept the 4 analog inputs at pin 1 to 17, 18, namely as the AN-I2, AN-I3, AN-I0, AN-I1 respectively. Then MCLR, master clear, is the active low reset input. In case of the 16C71, it is also serves as the programming voltage input. VSS is the reference ground for the logic input and output pins. Port B is the port B bidirectional of the input-output port. Port B can be programmed by the software for the internal wake-up pull-ups and all inputs. RB0 is also having the alternate function of the external input. Port B pin number 6, 7, 8, 9, 10, 11, 12, 13. Then VDD pin number 14. This is the positive power supply for logic and the input output pins. Oscillator C2 clock out pin number 15. This is the oscillator crystal output. In RC mode, the pin outputs clock output with the 1/4 frequency of the oscillator 1. This is also denoted instruction cycle rate. Oscillator 1 clock in 1. Pin number 16. This is the oscillator crystal input. It is also known as the external clock source input. The next one, the PIC reset circuit. In the PIC reset circuit, action the place due to the different mechanism of the PIC microcontroller. Those are the power on reset, master clear reset during the normal operation, master clear reset during the sleep mode, watchdog timer is reset during the watchdog timer reset during the normal operation. Brownout reset is not available in PIC 16C, 61, 62, 64 and 65. Out of all devices, 16C74 are the brownout reset feature. Power on reset and brownout reset action are discussed in next. The power on reset. The PIC reset circuit function very simple. The master clear pin, which is when the made low, causes PIC to the reset. A power on reset pulse is generated when VDD is raised detected. The range of the VDD through which it should rise from the 1.5 to the 2.1 volt. It is very simple to reset circuit can be pull up resistor through the MCLR tied to the VDD. The normally shows about the RC circuit is not necessarily added but is recommended by the microchip. The RC circuit reset circuit using the RC component as shown in the figure. This circuit is required only if the VDD power up slope is not sufficient. The value of R must be the 40 kilo to make sure that the voltage drop across the R does not exceed the electrical specification. 1K resistor, again the limits into the MCLR pin. Brownout, then next the brownout reset. In 16C61 and 16C71 does not support the brownout reset. There are many PIC microcontroller devices whereas brownout reset is possible. For example, PIC 16C66 and PIC 16C74 supported brownout reset. PIC can be reset automatically in running condition due to the brownout, which is not possible in the many other microcontroller. Brownout reset takes place when the supply voltage falls below the 4 volt. The device remains in the brownout reset condition till the power supply voltage is restored. Then next one is the PIC oscillatory circuit. The PIC can have the 4 different method clock, namely as the external RC, internal RC, crystal and external clock. A simple oscillator using only internal and external RC component is the simplest way of the oscillator connection. The figure shows the value of resistor and capacitor in the case of the external RC component are specified in the datasheet for the given oscillator frequency. Oscillator 2 pin out the 1/4 of the oscillator 1 frequency. The various clocking methods supported the PIC microcontroller. The connection about this PIC, the PIC oscillator connection with a crystal. The figure shows the crystal connection with the PIC microcontroller. C1 and C2 are the capacitor connected to the externally along with a crystal. Instead of the crystal, one of them may prefer a ceramic resonator on as a cheaper alternative where external capacitor are not required. A crystal has the better accuracy, and for the timing generation and the real-time application, one should prepare the crystal. Then next lecture we studied about the PIC memory organization. Thank you.